Welcome to our talk, Extending Spark with Java Agents. In the beginning, let me do a brief introduction. My name is Jaroslav Bachorik, and I'm a backend engineer. And during my career, I was involved in JDK development, as in the Java platform, and also on several performance monitoring tools like NetBeans Profiler, Visual VM, or btrace.
Hello, I'm Adrian. I'm a backend engineer with more than 5 years of experience right now in performance monitoring and profiling. Currently, I'm focusing on tuning and optimizing performance of big data applications. So we both of them met at Unravel. So Unravel is a startup in the context of performance optimization and monitoring of big data applications. So essentially, in a nutshell, what we do is monitoring and figuring out bottlenecks that slow down the application. So we focus on performance, speeding up performance of applications, and better utilizing the actual resources of the cluster. So during some of our work with the customers, we noticed that one of the big problems that they face is with caching. So caching, for instance, in Spark is a nice feature which allows you to basically store data, store RDDs into the memory, and reuse them whenever the same RDD is being reevaluated. So for instance, from the left-hand side, you can see an RDD which is being cached, and on the first action that will evaluate the RDD, that RDD will be cached into the memory. So essentially, it will be evaluated, and then for each executor evaluating that RDD, if we specify that we want to cache the RDD, we'll put it into the corresponding block manager. So the next time when we have the same RDD executing a different transformation on top of it and then an action, we'll check the block managers, we'll see if the data is there. If the data is there, we'll fetch it, and we'll avoid the expensive reevaluation step. So caching, obviously, it's a very nice feature. It can speed up the performance of the application. And also, we have other benefits, such as saving CPU resources. However, caching sometimes can also hurt on performance. And that happens when you cache data into the memory, and you cache so much data, and you need also to evict it, because we cannot store more data into the memory. So when you cache other RDDs, you may evict the previous RDDs. So there are many challenges that actually DevOps face today, and there are questions that are hard to answer. So the question is, which RDD should we cache in the first place, where to cache it, what policy to use, and basically the benefit really depends on the state of the memory state of the block managers. So it's really a challenge to figure out how to prioritize among RDDs. So we have basically at Unravel, we work on performance, finding bottlenecks, but also providing immediate feedback for the DevOps such that they can speed up the performance of the applications. So we designed an algorithm which can automatically figure out which RDDs are beneficial to cache, and essentially provide very concrete hints that can be used to tune the application. So here it's a sketch of the algorithm that we use. So in the first phase, we find the stages. Basically, we find the RDDs which are shared among stages. But then for the RDDs that were already cached, we want to evaluate the benefit. For the RDDs that were not cached, we want to see what would be the potential benefit. Basically, after we have all of this information, we run a prioritization algorithm, figure out which RDDs will boost more the performance of the application, and finally give some concrete hints to the end user. Now the question is, from where can we take all of this data? So we need information at the level of the RDD blocks, and some of this data is available in Spark through the use of Spark listeners. However, that is insufficient to actually run our algorithm. So we actually need some mechanism to get more intermediate information from the Spark engine itself, and we need to collect this data dynamically. So at this point, I talked with Jaroslav, which has a lot of experience in collecting metric information, and I will let him tell you more about the solution that we used.
Yes, so at this point I stepped in and I utilized my knowledge from the time when I developed for JVM, and I came with the idea to use the Java agent. Java agent, basically, in a nutshell, it is a binary which is sideloaded to JVM, and it's running alongside your main application. In order to start your application with the Java agent, you just need to provide minus Java agent VM argument, and then specify the agent jar file. Inside the agent jar file, there is an agent class, and the agent class is an ordinary Java class. The only requirement is that it must have pre-main function or method, and this pre-main method must be of the specific signature. When you have this, you can register the Java agent in the jar manifest file, and also in the manifest file, you can specify which other capabilities the agent is requiring from JVM. In our case, we needed the agent to be able to register class transformers, which can intercept class loading process, and they can change or transform the class data on the fly before actually the class is loaded by JVM. This way we could introduce some hooks into the bytecode and so on. So we specified can redefine classes capability. There's a bunch of other capabilities. The full list can be found at the Java-Lang instrument Javadoc. And armed with this, we can take a look at the class transformers. So let's say that we have this package private class, which is quite inaccessible. It's accessible only to other classes within the same package, loaded by the same class loader. And we are really interested in what is happening inside this particular method. The method is private, so it's even less accessible than the class itself. And we need to see what the input is and what the output is. We want to make sure that it's working correctly, whatever. And for this, we can either try to find the sources for this class, patch them, recompile, run it then. But it's, well, it might not be really possible. It is a lot of hassle for us. We could try using reflection. If you're lucky enough and something is leaking instances of this class, then you might be able to use reflection, but it's not always the case. With the class transformers, you can just take the class, inspect it at the class loading time, and figure out that inside the class data, there is this method, and you want to insert the callbacks, forwarding the input and output data back to your special analytics service, which you want to use. Everything is done without changing the source file. So also the good thing is once you remove the class transformer, the application you are running is back to the original state. So that's kind of volatile changes to the classes. A class transformer, is ordinary Java class, nothing magical. It just needs to implement class transformer interface with some handler for modifying the class data in the form of byte array. And using the class transformers, you can inspect, modify class data on the fly. You don't need to recompile, modify the source code. You don't need to access to the source code. You can introduce various powerful callbacks for your monitoring solutions, for your SLA collecting services. Or you can even patch problematic code. So you can create a hot patch loaded by Java agent and use this until the patch is actually actually makes the way up to upstream product. Then when it's an upstream product, you can remove the patch. You can remove the agent, and then you are good. Unfortunately, parsing the class data and modifying the class data is not a trivial task. It requires quite deep knowledge of a class file data structure and also some parts of Java class loading. Fortunately, on the other hand, there's a number of tools which are trying to help you with this. One of these tools is Btrace, which I happen to be maintainer and developer lead for that. And it's an open source tool. And it provides you with an agent, with Java agent out of the box. So you don't need to worry about Java agent. And also provides nice Java annotations-based DSL for class transformations. So you don't need to worry about all the class data parsing and modifications, whatnot. It is optimized for high performance, and it's used in other open source projects as well, so it's nothing really like bleeding edge that you need to be afraid of. I'm going to use the btrace DSL to walk you through this simple experiment. It's nothing in real life, just a thought experiment, how we could modify Spark configuration on the fly using Java agent and class transformation. So you all know that we have the Spark context, which is instantiated at the beginning of Java of Spark application, and that's the beginning. Everything basically depends on Spark context. So we intercept the Spark context, we grab the Spark conf instance out of the Spark context, and the whole Spark configuration, the Spark properties, everything is stored in Spark conf instance. And this is mutable. So when we intercept the instantiation of the Spark context before it is returned back to the caller, we can modify the configuration there, and then this configuration will be taken by the rest of the Spark infrastructure without noticing. This is how the btrace DSL looks like. So we have btrace annotation, which specifies where the code will be inserted. Here we are describing that we want to insert the code into a Spark context. In it means that it's constructor, and location kind return means that we want to inject the code before we return from the constructor. The Java method, the annotated Java method itself, specifies the actual code which will be injected to Spark context constructor. So you can write your functionality in Java there. Then the algorithm is pretty simple. We grab the configuration object, then we call some super advanced advice system, which will figure out what is the recommended number of cores we need to use, and then we get the number. We modify the configuration settings, and ta-di-da-da, everything is just marshals up to the rest of the Spark, and the application is run with your optimal settings. Okay, so it's quite a synthetic example, but this shows you how easily you can actually use this DSL to write the class transformers for your experiments.
Okay, so this is a very nice introduction of the btrace and Java agents. Can you show us how to actually use it for Spark, how to configure it for that?
Yeah, sure. Spark is, after all, a JVM application, so there's no difference between like Hello World, Java, Spark on Java. Any Java agent can be used there. And everything you need to do is actually modify extra Java options for executor and driver. That's all. Just put there this magical Java agent JVM argument, and you are done. And you can even store it in Spark defaults conf if you want to have it like system-wide. It's pretty easy. So having our data collection pipeline ready, we can now go back to our caching problem.
Okay, so let's go back to the caching problem that we have seen at the beginning of the talk. So essentially, I was mentioning that we need to collect a lot of extra data from Spark Engine itself. So by using btrace, we can actually do that dynamically and collect information such as block hit rate at the level of block managers, what was the potential benefit, how much time was actually saved by taking that data from memory and not reevaluating it. Similarly, for the cases that the data was not cached, we need information about essentially what would be the potential of caching, so how much time can be at the maximum being saved. And as well, we need some mechanism to evaluate what would be the size, the approximate size of the data that needs to be stored into the cache, right? And for that, we need some sampling mechanism and extrapolation techniques to figure out the actual, so basically the size. So we can do all of these steps with btrace quite nicely. Then we can run our algorithm and figure out which RDDs to cache, basically run the prioritization algorithm, figure out which RDD will give the most benefit, and prioritize to cache those in the first place. So just to give you an idea, how can we do this? So here we show on the left-hand side of the slide the get function from the block manager. And with bitrace, we can intercept this call as the call is being executed at runtime. And as it's being executed, we can actually also take some context information from the executing class at the runtime. So we can see, for instance, other context information, such as the current stage that is being executing that call, and so on. So how much time was saved by taking that data from the memory. So using this mechanism, we can use it for our algorithm. And here on this slide, I just show the end result of our caching algorithm. So essentially, we can pinpoint very concretely which RDDs to cache, what is the potential for caching. So basically, here it shows that 22 minutes were being spent recomputing the same RDD over and over again. So that's the maximum that you could save by taking the data from the cache. And then we give also precise advice on what statement at which line in your application you need to add a caching statement such that you can save time and speed up your application. Okay, so let's see now how can we put this on the cluster. How can we deploy bitrace on a distributed infrastructure?
Right. So far we were talking just about one JVM, one agent, but in Spark we have a number of JVMs running, right? We have the driver, we have a number of executor nodes, each running at least one JVM. And on all of those JVMs, we need to have the agent installed somehow. So what we can do, we can just grab the agent binaries, whatever files you need, all the jar files you are depending actually, and you can manually copy. You can just go and SSH or SCP to all the nodes around. While this is okay, you get what you want, but it's really time consuming, and after a while, you get fed up with that. So you script it, right? So you create a script for that. You can rsync, you can do anything more fancy, advanced, to make sure that you are having exactly the same binaries on all nodes, because that might be problematic. If you have changes in the agent, so you are building new versions of the agent, then you are trying to deploy it, and when you have some nodes running the old version of the agent, some nodes are running a new version of the agent, then you can start getting pretty cryptic errors. You are sending different data formats. You are trying to call different APIs. You might be missing dependencies. So you really need to make sure that it's everything, everywhere, it's the same. That's good. Just write a cron script. Just schedule it in cron, right? So it will take care of making sure that every day when you do your nightly build, you have new binaries. The cron will take the new binaries and will distribute it on the cluster. Well, and I think that's a valid solution. It's maintainable, and actually, I think we use it somewhere in some places. So don't be afraid. Well, of course. You can do that. I didn't have any pictures for Puppet. Okay. But when you're running Spark on Yarn, then you have the benefit of using the localization service. There's this service which, well, the first time I heard about localization service, I thought that it was translating the text to different languages. Well, it's not. It's taking care of distributing the resources across the cluster. So you just specify which resources need to be distributed across the cluster for a specific Spark application when you start the application, and the service will take care of grabbing these resources from the central place and putting them on each node in the cluster right before the application starts executing. I mean, the executors JVM start running there, right? Nice thing is that this localization service will create a link inside executor working directory. So you don't need to go to any cryptic locations on your disk to figure out where are your resources. You just use the name of the resource, and you do the /resource when you are trying to refer from the executor or from the agent, for our case, and it's there. So this is extremely lazy solution. You don't need anything else. You just specify what you want to distribute across the cluster. Localization service will take care of it. The details are described in the Spark documentation. It's a really exhaustive documentation. You can find everything you need about this. Opa. So during this exercise of figuring out how to solve the caching problem in Spark, we learned that sometimes even the really rich set of Spark data you can get, like Spark metrics, event logs, all the listeners we heard about just a session before. Sometimes they are not enough because you need to get the data nobody actually thought might be useful for something. So they are not exposed. So in this case, using Java Agent is a pretty good solution. It gives you the flexibility. You can use it until the data might be available by an official way. So it might happen that the data we are now getting by the agent will become available as a part of a listener in the future. But then it's no problem. We just stop adding the -Java agent parameter to what we want to run. And we will rely on the official APIs. So it's pretty easy. No modification in source code, no need to actually retest everything, whether you are not breaking something in your code by removing this part. So it's pretty useful and powerful. Then when you take a look at Java Agent class transformations, you can think of other usages. Like, as I mentioned before, hot patching or enhancements. You can inject, actually, some enhancements inside the product, inside the application, just for the time being. If you don't, sometimes it takes time till the patch makes it up to the main line. So till then, you can have your enhancement as a Java agent running alongside your application. And at the Unravel, when we went through all this, we actually learned to rely on the Java agents on quite a lot of functionality. We learned that it's quite easy to get started. Once you get past the distribution problems, once you get past the fact that you need to specify the arguments there, then it's pretty easy. It's the same process again and again, and you can do quite amazing things with that. There's the list of resources, just to make sure that if you access the slides, you can follow the links and you get more information. 30 minutes is not enough to tell about completely everything. So you can go to btrace. You can study the source code. So you can study examples. There's a ton of examples what you can do with that. If anybody is willing to contribute, I'm more than willing to accept. I'm always welcoming contributors. Questions are also welcomed about btrace. If you want to try out Unravel to see what we are able to do with Java agent and other techniques, because it is not solely that we are solely relying on Java agent. We have a bunch of different techniques we use. You can go to our site and register for free trial. There are no strings attached. You just register and you can try it out for a while. Spark configuration, that's good to study. And if you want to know more about Java agents, because Java agents are really, it's a broad topic. Today it was like maybe 10% of what is inside the Java agents I expressed. So just go to the official documentation, or there is excellent blog from guys from Zero to Round about how to start with Java agents. There's everything. If you want to write the agent from scratch, you don't want to use btrace for whatever reason, just go there and they will get you started in 10 minutes. Okay, Now it's time for questions and probably answers. Feel free to jump up and ask questions. Yes?
So yeah, we have 2 mics there and there for questions. And just as a reminder, if you are asking a question, please get close to the mic so we can actually record you. And I can get people down here with this mic.
Really good talk, thank you. I understand you're using Java agents to init Unravel. To use Unravel, you need to enable Java agent, right?
Yes, we also have a Java agent. So that's part of our solution, yes.
I'm going at solutions like EMR and Databricks. How can you integrate Unravel with managed Spark?
Well, for EMR, I think quite normal. We do it. Just specify. So when you have the cluster, you can specify. Okay, let me go here. I have. Okay, so I have some extra slides just in case we had more time. So basically, you can when you are submitting your Spark application, you can specify the extra Java options as minus conf parameters. So that you have a cluster and then you submit there. The only thing you need to, if you are using Yarn, is to have the archives, which will take care of distributing the agent binaries to the nodes. And as you can see, we have this, okay, it's not here, okay. So for the extra Java options, we are specifying the Java agent as a relative to the archive file name. Actually, that's what the localization service does for you. So it's really easy.
So basically a normal library that you can just add and
yes.
point to it with the conf.
Yes. For that Databricks, I guess it would be the same, but I haven't tried it. Sorry. Yeah.
I can let you know.
Thank you for the question. Yeah. Okay. Here's one question. Yes.
Okay. Hello. Thank you very much for the talk. Very interesting work. I'm going to try to keep it short, as I understand we don't have much time. I like the caching suggestions part.
Yes.
I caught myself thinking at the time when I was watching your talk that it'd be nice if that was part of the compilation process, so that we can see warnings coming in and suggesting what we can adjust, like, but that obviously cannot be the case because you have to run the whole thing in order to learn what optimizations you can do.
Yeah.
So can you give us an example of what can be identified when we run the program and therefore produce a suggestion? Because that would help me a lot improve my understanding of how the whole thing works.
Adrian?
Yeah, so you are right. So for caching, right, we need to process the data that we have seen in the past and then analyze it, get some suggestion. But for repetitive workloads, in many cases, that's very useful. So that's still it's a very valid use case. Now, in something that you want to benefit on the fly, so as Jaroslav showed the example with the Spark configuration, right? So you can maybe figure out some configuration at the runtime and just use them on the fly, right, without restarting the application. So basically adjusting some parameters just at the runtime. So that's a use case that we could use for, yeah.
All right, let's have one more question here.
Yes.
Yeah. Hello, thank you for the talk. I was wondering, what kind of rules or logic do you use to make the recommendations about caching? I mean, it's based on your experience, like which RDDs should be cached or not?
So definitely it's based on the benefit, right? So we, in a very, let's say, the simple recommendation is to look at all of the possible RDDs that are being reused, right? And just measure how many times they're being reused, how much time it takes to reevaluate them, and then make a sort and figure out what would give you the most benefit, right?
But
so,
how do you measure that benefit? I mean, how do you know? Like
so you would know in the first place how much time it took to evaluate it for the first time, because you need to evaluate it once, right? And subsequent times you will see it that you need to reevaluate it again if you don't have it in the cache, right? So you can make some assumption about how much time it would take if you would need to reevaluate it, right? So there are some approximation. It's not like the values are 100% it would be like that. There is some variability when you run your queries, but you have an estimation of what would be the cost to reevaluate it again. So yeah, so part of it it's modeling, part of it it's based on prior experience, what you have seen in the prior call, right? In the prior caching call.
All right.
Yeah.
Thank you.
Thank you.
Thanks.
So yeah, just a note. So if you are interested more in what we do, so we have some flyers just next to the microphone. Feel free to take them, and yeah, so ask more questions later. Thank you.
And also, you can find us in the venue. So if you have any more questions, just feel free to ask. OK, thank you very much. A great audience. Thank you.